Hi, I'd like to go over a very, very important videotape today on natural selection. This isn't in the older edition of the DAT OAT books, but I put it in the newer edition, and it's extremely important. It's extremely important you use the newer edition of the book as well, since I have all the brand new questions that you're going to be responsible for. Let's have a look. There's three modes of natural selection which can alter the frequency distribution of heritable traits. Now, these three selections will include stabilizing selection. Now, that means being average is best. And since we're coming to the end of this course, I think you all know me by now, I hate average. But in this case, average is good. Average is best. Variation is reduced, and we gotta keep the status quo and conserve the adaptive fit. An example. Most babies, as you know, should be about 7.5 pounds. Give or take a pound on either side, but if you notice, if a baby alters that greatly, it's usually not good. It's usually a pathology if he's born too light or too heavy. So that would be a great example of a stabilizing selection. I'll give you another one which we didn't do in the group. Light and dark mice are eaten more often than medium brown mice. Why? Because the brown mice can blend in with the soil. So as you can see, if you are light or too dark, then predators will gobble you up. These are examples of stabilizing selections. How about a directional selection? In a directional selection, one condition is favored over another. So conditions favor one extreme of a phenotype. A faster rabbit will be chosen selectively because he would be able to outrun his predators. So we choose the faster rabbit. How about morph color? This is interesting. In a sooty environment, as we saw, for instance, during the Industrial Revolution, right? If you have a sooty environment where it's polluted, dark-colored morphs will be better camouflaged, and therefore they'll hide from predators. So that would be a great example of a directional selection. And finally, a disruptive selection. Both extremes of a phenotype are favored. We see a division of the population into two contrasting subpopulations. Now, let me explain. That sounds a little confusing, that both extremes. Say, for instance, you have mice. The dark and the light are both good. Why? Because the dark can hide under rocks that are dark, and light-colored can hide under rocks that are light, and therefore the medium mice would be killed off by predators. So in that sense, we have what's called a disruptive selection. I hope this helps on concepts that are often misunderstood, and this is at the very end of the bio book. If you go to the Campbell book, this is way at the end of the Campbell book, and most kids don't think it's important. Extremely important. All right, I'll see you next time, and we'll do some more ecology. Bye-bye.